Yo, what's going on, guys? So, I'm back. As you guys can see, it's early in the morning, and we're gonna get back to it. So, we implemented the destroy food, and we basically got the food into the scene, and our food stays alive and stays in the scene no matter what. Whenever the food gets eaten, it respawns somewhere else. So we never run out of food for the agents, and we can specify how much food we want, as well as resetting the food every generation. We have the capability of doing that as well, already implemented. So now let's switch over to the Unity scene and see what's going on. Seems like we have a lot of useless prints in the project. We'll go ahead and get rid of that. So we have a lot of useless prints, but things are looking pretty good though. One more thing we're going to do is, now that we're in the Unity scene, we're going to go to the main camera, and we're going to move this from perspective to orthographic. And that way we can get a more flat, a kind of flatter thing going. The spheres won't look as circular, they'll look like they're 2D. And obviously this is a preference thing, you guys don't have to do that. You can choose to do that. And I'm also going to make the camera pretty big so that we can see the cutoff of the two walls on the left and the right. So if it hits the wall, we'll see things get, oh yeah, that's not gonna work, because we're spawning based on the viewport. So the viewport has to be within the walls. And there we go. Let's go to the scene and see what's going on. Since the top and the bottom walls are kind of a little too far up and a little too far down, we'll change that. We'll change the Y on them to, let's say, 25. Okay, and then the bottom one will be -25. Interesting. Let me make sure the camera is zeroed, because these two should be about the same length apart. And as we can see, the camera on the Y is actually above 1. So let's move that down to 0, and now it's perfectly centered. Okay. And our fish get spawned, and if they touch the wall, they die, but as you can see, they do react when they get closer to walls or sensors touch seawalls. But one more thing to note is that the fish cannot see the food. Whenever a sensor goes over the food, it simply doesn't do anything, because we have not added sensors for the food or tags for the food. So we'll deal with that after we add some energy. So right now they just keep spinning, they live forever. We want them to die if they don't touch the food. So we'll go to our code. We'll go to our, since we're done with the food manager, we'll cut that, we'll X that out. We're done with the food controller, we'll X that out, and we'll now be in our fish controller script. So in the fish controller script, we want to add energy, and then we also want to add, since we're going to take care of adding energy, after energy we'll add the fitness function for this. And to begin with, we're going to do a naive implementation of the fitness for this fish. And then after our mutation is done, I'll show you guys how to make that better. Alright, so we have our overall fitness here. Right here, then we want to create a private, oh no, not here. So private float energy. No, we will name this current energy, and then private float total energy. So actually this will be public. So the total energy will be the what we're using to define what the energy should be at start. What is the starting energy? So is it 5, 10, whatever? And then the current energy is what the energy of the fish is currently. Okay, every update function will decrease the current energy, so then it will slowly get go down to 0, and once it hits 0, the fish will die. Alright. So now, right here, I'm actually going to add a header because I'm going to start trying to block the things off in the fish controller. So we'll do header, and we'll put a header. The header will be energy options. Okay, so in energy options, we'll define the public energy, and we will also be able to see that's fine. We'll also be able to see what the current energy is. Sorry about that. So we'll have the total energy and also be able to see where the current energy is. Now that we have that done, we will create the function that slowly, actually, yeah, alright, that's fine. We'll create the function that slowly takes away from the energy. We will call that function update energy. So right here, nope, we'll do it above the collision and above the death. Right here, void update energy, and that will simply take the current energy and subtract time dot delta time. So it will be slowly subtracting time dot delta time from the current energy, making it go get lower and lower and lower. Alright, now we want this to be called in the fixed update. However, well, right now we'll call it in the fixed update, but in the future we want to call the update energy function inside of the calculate fitness function. The calculate fitness function will be called in the fixed update. So every time, every fixed update, we want to update the energy, then calculate the fitness of the fish, and then pass that back and just store that, and then wait to see if the fish dies. Okay. So we'll be updating the energy, and then in the future we'll be updating the fitness, and then when the fish dies, that fitness value gets given to the genetic manager. Alright, so for right now, just to see how the energy updates, we will do update energy, and basically just like that. Alright, let's go to our Unity editor. Let's go to the Unity scene, and then let's go to project, prefabs, and the fish. On the fish, scroll down to where you have your fish controller. And over here on top, we see energy options. And what we want to do is set the total energy to, let's say, something like 10, and then we'll see in the beginning. Oh, wait, I still have to set the current energy. So let's go back to the script. On the start, we want to set current energy equals to total energy. So right on the start, we have the energy equal to total energy. Go back to Unity. Alright, so let's press play and click on a fish. Oh, clicked on food instead. As you can see, the energy is constantly going down. Right now it hit negative, but we're going to have it to where once it goes 0 or lower, the fish dies. So it won't ever get negative like it is right now, but it clearly is getting lower and lower and lower. Okay, I clicked on it to stop it, but you know, it'll keep going. Let's go again and let's see how it's if it starts. Yeah, see, it starts, we don't see it because we don't click on it fast enough, but it does start around 10. So it's not like set to 5 or something. You know, we saw that it was at 6, so it's probably started at 10. It took us a little bit of time to get to it. Alright, so we have our energy and we have our fish. Now, I want to add some headers to the fish controller because it's not really looking that pretty. Okay, the brain index is we will from here, the brain index input output node, we will put network settings as the header for this. Network settings. Alright, let's go back to the editor and just see how that's looking. Click on the fish, scroll down. Click on the fish prefab down here, and then scroll down to where the right, you see how energy options has the header right here, and then the network settings has the header right here, and then we actually have to get rid of acceleration and turn next. Let's go back. Let's get rid of acceleration and turn. Save that. And let's go to Unity, make sure there's no errors. Yep, everything's good. And now we just have to get rid of the debug.logs that we have. We'll get rid of that debug.log because we know it's working. Oh, but don't get rid of it, just comment it out because we might need it in the future. Okay, we only had a 2 here, but I know we have a 20 somewhere being printed, and I believe it's being printed in the food manager. Yep. So we'll save that. We'll save this, and no errors, I assume. There's nothing really changed. Yep. Awesome. Let's go back, and now let's implement the death once the energy hits 0. Okay. But before we do that, let's implement the fitness. So the way we're going to do it is death is going to be checked in the calculate fitness as well. So in the calculate fitness function, there's going to be a lot of things happening because the calculate fitness is kind of death is kind of goes hand in hand with fitness in this example. So we just kind of manage it through there. Alright, so what we're going to do okay. So let's now create some more variables. We have the energy options and we have the network settings, but right underneath energy options, where it says overall fitness, we're going to create a new header. And we're going to call this fitness options. And that's where our overall fitness is going to be. Which I'm going to make public for now. And that's then also where we're going to create the 2 storing variables, one for how much food is being collected, and then the other for the multiplier for the fitness. So whenever a fish eats a food, we're going to give it 5 points. And then when fitness is being calculated, we'll multiply 5 points by some type of constant to scale it. Okay, so like 5 times 2 will be 10. And then if the fish collects, let's say 20 fishes, 20 food, their fitness score will be 20 times 5 times 2. Alright, so let's set that up. We're going to do public int we'll call it food captured. Let me see what I call it in my reference code, because it'll be easier to just have this match. Food since start. Alright, that's fine. So how much food has been eaten since the start? So we'll always start that off at 0f, because when we start off, no food has been captured. And we're also going to have a public float for the food since start multiplier. That's a little long. Food multiplier. Am I spelling that right? I hope I am. See, I can code, but spelling, that's my downfall. Okay, so we have our food since start and our food multiplier. The food multiplier we will define in the editor. Okay, so we have our two functions. Now let's create, wait. Before we create the fitness function, let's go down to the onCollisionEnter function. And where it says food, you see where we have the overall fitness being increased. Instead of doing that, we just increase the food since start equals food since start plus 1. I said we were going to give it 5 points, but let's just add 1, and then we'll use the multiplier to scale it up and down. Okay? And instead of doing that, let's do plus equals 1. Okay. So that's actually perfect. Because when we do it's destroying the, okay, good. So food since start plus 1, that's perfect. Now, whenever the fish eats food, it will get a reward. And this is its reward. Because in the fitness function, we will multiply food since start times the food since start multiplier. Okay? So the fish did good, and it got the food, so it gets a reward, but it also needs to get energy, because its energy is constantly depleting, and if it hits 0, it dies. The food is supposed to give it energy. So for the energy, I'm thinking about just having a variable instead of having actually what we will do, this is going to be better. So current energy equals what we will add to the current energy half of what the total energy is. Okay, so the total energy, let's say, is 10. We don't want food to ever give more than 10. Okay, which is why we're dividing. But mainly because then it's too easy for fish to live. Okay, so let's say we start off at 10 energy. Anytime a fish captures food, it will get 5 energy back. Okay, if I do times let's say 5, then it will get 2 energy back, right? So we're going to keep it like this, and we'll scale it up and down how we see fit. Or in the future, we'll just add a variable that is how much energy we want to give to the fish. Okay. Actually, let's just do that now. Why not? So we have our total energy, and then right underneath total energy, we want to add public float add to energy, and that is what we're going to add to the energy. We will change the name to reward energy, because this is the reward that the fish is getting, and it's the energy reward, not the fitness reward. So change up there to what did I change it to? Reward energy, and then come down here and change this to reward energy and save that. And now whenever a fish captures food, it will get energy and it will get fitness reward. Okay, so now that that is done, we can begin to calculate fitness, because we have the value we need to calculate the fitness. So what I'm going to do actually is I'm going to cut this. No, I'm not. It's going to start getting confusing. All right, right underneath the fixed update, we're going to implement the calculate fitness function. So for the calculate fitness function, we're going to be calculating the fitness, but then we're also going to be checking to see if the energy is too low, and if the agent needs to die. So, and we're going to be updating the energy in the calculate fitness as well. So there's a lot going on. Calculate fitness. All right, and then the first thing we're going to do is cut the energy, update energy line from the fixed update, and add that into the update energy function, into the calculate fitness function. Add update energy into the calculate fitness function. So now that that's done, we can calculate the overall fitness. So overall fitness, and this will be done in every update, overall fitness equals food since start times energy multiplier. Or food multiplier, that's what it is. There we go. And why is that capital? That should not be capital. Go back up right here. This should be camel case, should not be capital. So scroll back down to where that is, change that to F as well, lowercase f as well, and let's close that off. And that's basically our fitness function for now. This is not the best way to do the fitness function for this this problem. Okay, even though it seems like the best way to do it, because I mean, when you really look at it, it's just the fish need to go get food, right? And that should be their fitness. More food, that's what we want them to do. However, there's better ways to do it, and one of the better ways is we should also reward for speed. If fishes are catching food faster, they should be getting rewarded. So we will add that, but for right now, we're just going to leave it like this. So now that our update function is done for the calculate, the energy is being updated, the fitness is being calculated, we need to add the depth. So we just do an if statement, current energy is less than or equal to 0, then we call depth. Pretty easy. And that is our fitness function, simply. We call that fitness function right in between the input sensors and the feed forward loop and the fish move. Actually, we'll call it right at the end. So right after a fish moves, the fitness is calculated, and then the next move is done, and then fitness is calculated to see if it's a good move. Okay. And that should be good, but obviously, there's always errors. Alright. You can call float to int. Put 233. We'll change this food since start to a float. What we're doing wrong is we have int here, we have f here, we're converting to a float. And we're gonna leave it like that because we don't know if we want we don't know how we're going to handle the food. Right now we're adding 1, but we might change that to like 0.5 or something. It's better to have it a float for now, and then we'll change it back to an integer if it's if we need to for optimization. So it's always good to write your code optimized, but then I always feel like it's really, really good to go through your code at the end of it to optimize it even more. Alright, so that's done. Let's press play and see what happens. Alright, and then death is called. They're all dead. So they all for the most case, they uniformly ran out of energy because there was not enough food. But let's go to the food manager. Let's up the count to, let's say, 200. Now we have a lot of food for them to even accidentally get. So we'll see some fish just surviving. There'll be different length intervals of survival. Well, they should have been. That fish clearly got food. He should live longer than the other fishes. However, he didn't. So let's think about why this is happening. And now debugging becomes even more difficult because we have just a bunch of fishes flopping around. You know what I mean? We don't really know exactly what's going on here. But we'll figure it out. So let's go to the code, actually. And what I want to do is just trace how the fitness is calculated and how the agent gets its energy, right? So whenever it touches food, current energy should equal the reward energy. However, I do not believe we set reward energy to equal anything. Did we? So let's now look at the code to see if reward energy is actually equal to anything or not, or if it's just 0. So to see where to set the reward energy, you go to the fish prefab and you go down to the where the reward energy is, and it's 0. So the fishes aren't actually getting rewarded for catching the well, they're getting rewarded for the fitness, but not for the energy. So yeah, that's why they're not living any longer. They're not getting any energy. And now we should see different death rates. Like fishes should be dying at different times. You see now there's no sudden death of all fishes. And these fishes that are surviving have actually just accidentally stumbled upon food. They just got lucky. because there's so much food in the field. They could just spin in circles and keep getting food. So that's why it's important to not have too much food in the scene when you're training as well. Alright, but it's very clear that these fishes are not actually doing anything spectacular. You don't see them turning towards any food pieces. Okay, that's how you know that this is a untrained network. They are just spinning in circles. When we do the training, once this is done, you guys will see there will actually be chasing behavior. And then, after we get chasing behavior, if we add movement to the food, that's an interesting idea. Will they chase after the food that's moving? How accurate will they be on a moving target? So we're gonna test all these things out, depending on how the initial videos get views. You know what I mean? I'd love to like keep making things and using Neat up to like a zombie game, but it's all depending on how the views go. And I do apologize for these videos because this is my first code along. You know what I mean? So practice makes perfect, and I'm gonna get better at this. So yeah, just let me know if you guys want a tutorial. That'll be more interesting. So it'll be something where I write down things and actually have things set up. So it's interesting. This fish is surviving longer. It's just way super long. Okay, let's go see how much its fitness is, or how much its energy is. I just saw it. There it is. This fish has 144 energy. He'll just keep going forever. And he's gotten 28 food pellets since the start. So in contrast, let's move the food down to 20 and see how well the fish survive. So we have 20 pieces on the board. It's harder to get food randomly. And we see a lot more dying off a lot easier. And they're all gone. There's less of a chance to get random food, and so they die more uniformly together and in shorter time intervals. Alright. So, I mean, yeah, the energy is done, the fitness is done. The only thing left for the genetic manager is the generations. Every generation we want to spawn the next group. For that, we can spawn the next group right now, but we also, every group needs to mutate. Every generation needs to mutate. Right now, all of our networks that we're creating are given 3 edges on random, which we specify in the Neat network. So we have that hard-coded in. We don't want to do that. We want to get rid of all edges, start off with no edges at all, and then have it to where mutation adds edges. So in the first generation, we could have it to where all of the fish start off with no mutations and no movement and an empty network, but that's kind of pointless. So in the first generation, we should have 1 run of mutation, right? So 1 edge might get created or 1 node might get added, and then we do and then we keep doing mutations every generation, and we because we're getting fitness calculated through the genetic manager, we will slowly find the best fish that is solving for this scenario through randomness and rewarding fishes that are doing good and getting rid of fishes that are doing bad. And that's why this is Neat is NeuroEvolution of Augmenting Topologies, because it's using evolution to augment the topology of the structure. Yeah, so the topology is the structure, and it's using evolution to augment the structure of a neural network. So let's now move on to the next part, which is adding the generations and then adding the evolution part, the mutation part. All right. So to do the To do the repopulation part of this, we're going to first do the repopulation, and we're going to do the mutation at the end. That is going to be the last thing we do before we finish this part of this little series up. And then I'm going to post these videos and see what the response is. If people want to see speciation, to see the different colors and to see how mutations are taking effect in the and creating species, then we'll work on that next. Okay, and saving the graph and visualizing the graph, things like that. There's still a lot of cool things to do, but we are coming close to that. So before I start with the next thing, let me see how long this recording has gone. We're at 35 minutes. I'm gonna stop this recording and I'm gonna start a new one.